Hello everyone, Swagatam and very warm welcome to all of you at this amazing platform of PW. My name is Aman, your maths buddy. Yes, I'm over here on your demand. Now, recently from our channel, we have put up multiple resources about the Aryabhata Ganit challenge. There were many students who were clueless what this Aryabhata Ganit challenge is all about, and there was other set of students who were not having any understanding how the questions in this examination would be different from the questions in your regular examination, because the course structure is almost the same. We are having the same topics like number system, geometry, mensuration, stats and all these things. So the purpose of this video over here, first to educate you about Aryabhata Ganit challenge, and then to show you how the questions would be different. I have picked up the questions from the first stage over here of the chapter of number system. From the number system, we'll be solving few questions over here and we'll get the clarity how the questions are different and how your conceptual clarity will be playing an important role. So about Aryabhata Ganit challenge, CBSE each and every year conduct a talent hunt examination. Over here, the whole purpose is to check how much real life application of mathematics is there among the student, because learning maths, scoring marks, that all is fine, that everyone is doing, but how well are you able to apply whatever you are learning in the classroom? So for that they have two-stage examination. First they do this school stage screening, that is first test, and then we have the national level competition, which this year would be conducted on the 3rd of October. Yes, the time is almost there. So that is the reason we are also over here. So without wasting any more time, to help you understand what kind of questions would be there and how you have to approach the preparation, we are over here to start with the chapter of number system and solve few questions on number system. So let's start with the first question given to us. It says if a number is first multiplied by 4 by 7 and then divided by 12 by 7, then the equivalent to which of the following operations on the number? Multiplying, dividing by which number? Ultimately, they're asking you what kind of operation needs to be conducted or the simplification of what operation they have already conducted. So let's work upon that. Let's talk about it. We are having a number. Whenever we don't know any number, what we do? We check with our favorite variable. It can be x. If someone is not favorable with x, so they will be going for ABC or PQR, whatever you want. I'll start with the x. I am taking the number which is unknown to me as x. They are saying multiply by 4 by 7. I am multiplying it by 4 by 7. Then they say then divide by 12 by 7. Divide by 12 by 7. So now that is all. Now the question on face value is very simple, but it's conceptual. How conceptual? Many of the students will be getting confused in this calculation over here. 4 by 7 divided by 12 by 7. One basic understanding should always be there. What, sir? When you are dividing any number, that is nothing but multiplication of the reciprocal. Multiplication of the reciprocal. What I am trying to convey? See, A divided by B. This is what we say, right? A divided by B. So how can I write A divided by B in the form of multiplication? I can say A multiplied by the reciprocal of B, reciprocal. So A multiplied by 1 by B, and hence it becomes A by B. You write A by B multiple times, but you don't have the clue how it reached to A by B. This is the thing which have to be checked over there, assessed over there. The understanding of the things, so basic clarity are there or not. So conducting the same operation over here, x into 4 by 7 over here, multiplication. I'll be converting division in the form of multiplication and taking the reciprocal of this number. So 7 by 12. 7 and 7 get cancelled out. 4 will be cancelling out 12 3 times. What is left over here? X being multiplied by 1 by 3. If you observe, ultimately one operation is being conducted. What is that operation? Sir, the operation of multiplication is being conducted over here. And that operation is being conducted along with the number of 1 by 3. So final answer will be what? Looking into the options we have, we have multiplying by 1 by 3. Any other option? No. This seems to be the perfect one and this seems to be the answer. That is it. See, the question was very simple. If you have the clarity, you'll be able to do it. Otherwise, you'll be struggling on that part. So without wasting any more time, let's move on to the next one. The next question over here talks about the sum of odd numbers from 1 to 2019, both inclusive. So first of all, stay over here. We have to add odd numbers. We have to add odd numbers, getting confused between add and odd. So over here, 1 plus 3 plus 5 plus 7 plus 9 plus 11 and so on, up till where? 2019. So the thing is 1 plus 3 plus 5 plus 7 plus so on and on up till 2019. The first question comes, how do we do the addition at the first place? Is it possible to do the addition manually? Or even with the calculator also your fingers will be very stressed out typing these many numbers. So no, that is not the method going forward. So what can we do over here? If you have learned the chapter of squares and square root, odd numbers can be easily simplified. Odd numbers can be easily simplified. This is the thing. See, learned in the grade 8th and the property is used over here at the national level examination. Very simple. Over there, the property is there. The property is if we have odd numbers 1 plus 3 plus 5 plus 7. If I go on adding, and I am taking in total n terms. In total n terms I am taking. So the sum will be what? The sum will be the square of n terms. The sum will be the square of n terms. N square. So over here, how many terms are there? Don't get confused saying that I'll be doing the square of 2019. No, we don't have to do the square of the final term. Total number of terms. How many terms are there? So there can be multiple methods. Either you can go by APC. We have used the chapter of square and square root. We can use the chapter of AP as well. But it's not always you have to go by the complicated method. Apply your mind and go by the simple method. If I am talking about between 1 to 10, how many odd numbers are there? 10 by 2, 5, sir. If I say how many odd numbers are there between 1 to 9, again the same thing, it is still 5. So if I add one number to 2019, that means 2020. And if I divide by 2, it will give me the total number of odd numbers starting from 1 to 2019, and that comes out to what? 1010. These many odd numbers would be there among these. So what I want the square of this. So square of this is what? 1010 square. Again, there is always a way to find the squares of numbers. You can go by the long method of multiplication, or you can go by any other method. One way of looking at is I can use the identity 1000 plus 10 whole square. 1000 plus 10 whole square. This is another way you can go forward. But anyhow, whatever will be the square over here, the square of this number will be coming out to be 10200100. This will be the square coming out. Once you have the square, now go up to the options. They are asking about the divisibility. Divisible by 100 or 101. Two options are there. Either by 100, 101 or by both at the same time. So, two zeros at the end. One thing is for sure, that can be divided by 100 because 2 multiples of 10 will be dividing the 2 multiples of 10. So, that part show that can be divided by 100. Yes, for sure I can divide by 100. For sure I can divide by 100. What about 101? I am having 1020100. What about 101? If you observe the numerator, 102. If I divide by 101, what will the remainder? I think 1 will be the remainder. That much you can think of. Now, what is left? 101. Again 101. That can be easily divided, and thing is done over here. Yes, it can be divided by 101, and we have the answer what? Not only 100, not only 101, both 100 and 101. Option number C. See, question is related to number system. There are concept of squares and square root. There is a concept of AP. There is a concept of divisibility as well, which you learn in number system itself. So basically, we are dealing with numbers, but the holistic understanding of the things are very important over here. That is the way forward. So we also move forward on to the next question. It relates to the set theory. Now, we have on Thursday night, they are having a Thursday night, 120 college students are drinking coffee at the local cafe. So, college students are there, not the school students. So, don't get excited that, okay, we can also go out on some day in the late evening and have coffee. Each student brings either cold coffee or black coffee. So, two kinds of coffee are there. I hope you are familiar. You might be saying, sir, hot coffee and cold coffee. Yeah, hot coffee is there, but black coffee is one form of coffee where just simply add and have the coffee. Original taste of coffee, to be very honest. Going further, 1/3 of the students are females. Now, coming to the important information, end of the chit chat, 1/3 of the students are female. Okay, so number of females, how many females do we have? 1/3. 1/3 means 1/3 of total, that is 120, right? So I believe this will be 40. Fine. And 1/5 of the students drink black coffee. 1/5 of the students drink black coffee. So how many drink black coffee, sir? Black coffee. See, black coffee, how many? 1/5. 1/5 drink black coffee. So 1/5 of 120. So this will be coming out to 2 times 10, 20, that means 24. 24 students are drinking black coffee. Fair enough. Next statement says if 10 of the students are male and drink black coffee. So they are male at the same time they are drinking black coffee. So 10 students are there. 10 students who are male as well as drinking black coffee. So among 24, if 10 males are drinking, so how many female drink black coffee? How many females? Female drinking black coffee. The combination of female and black coffee. Definitely it's more than male at the moment. This will be what? 24 minus 10. I think this will be 14. And I'm over here explaining the things. See, I'm explaining the things and taking so much time. Don't think that this is the manner you'll be writing in the exam or solving in the exam. It has to be a quick succession of thoughts. Quick succession of the thoughts and immediately going for the answer. Be sure. And how will that come? By practice, more and more practice. So going further over here, 14 will be drinking black coffee. So I want the number of females who are drinking cold coffee. I know total number of female. I know number of females drinking black coffee. So female and cold coffee, the combination of female and cold coffee. This number will be very simple. Total count of female is there minus the count which are drinking black coffee. So not 12 over here. This is 14 over here minus 14. So this will be 30 minus 4, that is 26. Our final answer. Do we have any option? Yes, sir, we have the option. Option number B. And that is how it's done and dusted. Alright. So read the statements carefully, go forward. Read the statement carefully, go forward. See, I have given the complete explanation. This is not what we have to write. This is what we have to think immediately and go forward. So going forward to the next question over here, which relates to experiment, which is also a part of number system basically. So over here we have 2 into 5 raised to the power x. This is being equal to 10 upon cube root of 25. Now, the basics of experiment, whenever we are having an equation, always make sure that the two numbers should have the same base on both the sides and then do the comparison of their exponent. So, applying the same logic over here, 2 and 10. When I transfer this 2 on the other side, it will be division. So, I can cancel out 2 dividing 10, how many times? 5 times. So, on the left hand, I have the thing which I want. I want to find the value of x. So 5 raised to the power x. Now I just need to convert the right hand side in terms of base as 5. And whatever be the exponent, that will be equal to x. So let's try to solve. This is 5 upon cube root of 25. Cube root of 25. I hope everyone in the classroom knows that 25 is not 2 into 2. Even I don't know. 5 into 5. That means 25 is 5 square. If it is 5 square, so over here it's cube root. I have made a mistake. It's a cube root of 25. So I can write this as 5 upon. Now another concept, another important concept I hope you would be knowing. So if you are taking any root, nth root of a. So what does that mean? A raised to the power 1 upon n. This is the concept which you should be knowing. This is a concept which you should be knowing. If you don't know the concept, then you are in the wrong class. This is an important concept in exponent which we learn. So that is the reason when we have square root of any number, we write it as the number raised to the power 1 by 2. Or we have cube roots, so number raised to the power 1 by 3. So same I will be doing over here. So 25 is 5 square. And further to that, we have the number raised to the power 1 by 3. 1 by 3. Alright. So further simplifying, 5 raised to the power x. Taking this in the numerator part, 5 into, first of all understand, whenever we are having two numbers, further an exponential number raised to the power exponent. So the exponent get multiplied, a raised to the power m into n. So over here, 5 raised to the power 2 into 1 by 3, so 2 into 1 by 3, that is 2 by 3. Two numbers in the case of division, so they will be what? The exponent or the powers will get subtracted, m minus n. Right? So doing the same thing over here, we were having 1 over here. From here we get 2 by 3, that will be subtracted, minus 2 by 3. I hope you know the calculation for this part. 3 minus 2, that is 1. So 1 by 3. And from here, I can write down that the x will be 1 by 3. With each and every step, I have done the solution over here, and I believe you will get the clarity what we have used. Ultimately, what was important? Ultimately, the laws were important of the experiment. Nothing more than that. If you know basic concept, question, be it from the textbook, be it from anywhere, it will be solved. Alright. So let's try to solve the next one then. The sequence, this is the sequence A, the first term A, then the second term 20, 37, so on. We are having 71. 16, 27, 37, 49, the next term 71. So we are having two different APs and both at certain point of time having numbers 71. Each have 71 as a common term, Now the next term which will be common, a very good question, a very, very good question. See, how would I get the common term? We'll get the common term if the common difference, I hope you know the common difference, the difference between the two consecutive terms. If the common difference is having some LCM, and that LCM will be repeated time and time again, right? Let me show it to you. Over here for the first AP, what is D? The D over here is 20 minus 3, that means 17, right? For this one, what is D? If I am saying this is D1, this is D2. So for this, 27 minus 16, that is 11. So D1 and D2. When we are having two terms and I want to find the LCM, and I know that there is no common factor. 11 is a prime number, 17 is a prime number, and I want LCM. You can think about it. If I want the LCM of 2 and 3, it will be 2 into 3, 6. So I can multiply in that case to find the LCM. So LCM would be what? 11 into 17. 11 into 7 is 77. 11 to 1 is 11. 11 plus 7, 18, 187. So this is the LCM ultimately. So after this much count of 187, another time, whatever be the next term comes up, that will be common for both the APs. So after 71, how many? 187. 187, after 187, then the number will be same. So that means 71 plus 187. Let's do the addition. 7 plus 1, 8. 7 plus 8, 15 plus 258. Do we have any option? Yes, sir, we have option number C. That is the answer. This is how we need to proceed. Understand once again. In the case of AP, the number will be repeated. Numbers are repeated when they will be having a common LCM. That common LCM will be repeating, right? 187 is a common LCM. After 187, again they'll have the same number. After that, 258, again add 187. Then we'll have the same number. Think about it. You'll get the clarity. Take up the example of any other AP and try doing the same thing with that. Then you'll get a much more clarity. It's all about the application. How further you can think of. The next question over here says, find the remainder and the last digit of the equation of 0 of 1, 1, 1, 1, 1, 1 and going on. I would not be able to read the expression because it will be a very long expression. I will not be able to read up till 24 digits. So I have read up till where it was possible for me. What I want to divide this complete expression by 7. When I want to divide this complete expression by 7, so what will happen? When I divide it by 7, so I want the equation as last digit of the equation and the remainder. Would I go for the manual calculation? I don't think so. If I am sitting in a national level examination, there would be other method, right? So understand in this manner. Alright, if I want for this such a big number, the good thing is all the digits are same, 1, 1, 1, 1, 1. So if I observe the pattern, if I catch the pattern, then I go forward with the same thing. Like 24 is what? 24 is 6 into 4. 24 is 6 into 4. So if I check for the first 6 digit, whatever be the nature of the problem, that will be repeated 4 times. At the end of the 4th time, it will be same as it was after the first time. So what I am saying over here, if I check for 1, 1, 1 and 1, 1, 1, this is 6 digit number, and if I divide the division, if I check for the division by 7. Now, whatever happens over here, the same thing will be repeated 4 times. Understand? So dividing by 7 over here, 7 4 times, 7 1 times itself is 7. So we are having 4 as the remainder, 41. Okay, 41. So 7 5 times is 35, 35 and 41, 6. We are having 61. Alright, so 61, 8 times is 56 and 61. So how much is left? Again, we are having 5 this time. So 51. Now for 51, 7 times is 49. We are having 2 as the remainder, 21. 21, sir, 21, 7, 3 times is 21. We have divided the 6th digit and we have got this much as the equation. And how much is the remainder? Remainder after over here is 0. For 6 digit, this is the final count. If I take the next 6 digit, if I take the next 6 digit, if I take the next 6 digit, again the same pattern will be repeated. So what will be the remainder towards the end? Always the remainder will be 0. What about the quotient, sir? The last digit of the quotient, the last digit. So the last digit of the quotient will be what? 3. We are having 3 over here, so it will be repeated. Towards the end, it will be again, it will be 15873, 15873, 15873. Ultimately, last digit will be 3. And the correct option over here, the correct option over here will be what? Remainder and quotient, so 0, 3, so 0, 3. Here we go. That is it. That is it. So that is how the problems have to be proceeded with. And that is all the problems I have in today's session. Interestingly, all the problems were from number system. But if you observe, in your textbook, you will not have the same nature of the problems. They will be giving you some theorem, they will be explaining that, okay, this is the application of the theorem. So direct questions are there. Formula is learned, answer would be implemented directly by applying the formula. You have to avoid that vicious circle and think about the real life problems. Now this is a number case. In the case of quadratic equation, in the case of geometry, there are multiple real life problems which have to be solved. Think in that manner. For the exam, make sure that you have checked the previous year paper, make sure that you have a proper time management, make sure that you are practicing more and more. Ultimately in mathematics, that is what helps. So best of luck, make sure, stay calm and be positive. You will be going ahead and representing yourself at the national level. Have a great time, enjoy yourself, bye bye, take care.